Okay, so our next example is, if you could see in our example is linear in y, right? We have your dy, you have your y, you have your p of x and q of x. So the difference of this is later on we will have a longer solution because in this problem we will be encountering, integration by parts. So the problem is just simple to look. So let's try. Okay. Let me copy. Let me copy. So let me copy the problem. So the problem is dy over dx plus y. So let's say if the given is like this, 2y equals 4x cubed. Okay. Let's say the given is like that. Okay. So the given is like this. So we know that we will be using linear in y. So this form is the standard form of linear in y. So from here, okay, we will now get our p of x and q of x. So we have here dy over dx. So the question is, what is our p of x? So again, we need to put the y, and what remains are all p of x. So we need to just separate a y, and the one that remains there is your p of x. The same as your p of y if you are in linear in in x. So equivalent to 4x cubed. So therefore, our p of x will be 2, just only 2. And q of x is equivalent to 4x cubed. So your p of x and q, you can just have a constant for your p of x. No worries nga, sir. It cannot be p of x because it doesn't contain a variable x. It could be. Okay? So now let's continue. We have already the value of p of x. Therefore, we could now solve for our integrating factor. So we now solve for our integrating factor. So we have integrating factor here. Integrating factor, which is e raised to the power of integral p of x dx. So therefore, integrating factor is e raised to the power of integral of 2 because your p of x is just 2 dx. Now you have e, move the constant outside. So now you have integrating factor of e to x. So therefore, this is your integrating factor. So this is now our integrating factor. Now we could solve for our general solution. So let's write it here. So general solution. Okay. So our general solution is in linear in y, that is y times integrating factor, okay, times is equal to the q of x times integrating factor dx plus c. Very good. So now we need to substitute. What is our integrating factor? That is e raised to the power of 2x equals q of x, that is 4x cubed times e raised to the power of 2x dx plus c. So we have y e2x equals, moving the constant outside the integral sign, you have x cubed e2x dx plus c. In this case, we cannot use our 2x as u compared to the last time we have y squared na pwede natin i-use so that we can cancel. Because when we derive the 2x, you only have 2 and that is not x cubed. We cannot cancel. So therefore, we will be using IBP or not siya blood pressure, that is equivalent, that is integration by parts. If you could still remember your calculus, so this is discussed in your integral calculus. So let's just use what we have learned in integral calculus. So integration by parts states that u dv is equal to uv minus integral of v du. Okay, that is integration by parts. So from here, therefore, in this case, we need to decide. So let's have this one. Okay, let's solve this one first. We have equals, solve this one first, for integral of x cubed e2x dx plus c. So from here, just copy na lang, e2x. So from here, we need to decide what is your u and what is your dv. So if this is your u or this is your dv. So in this case, if we use this one as u, when we derive this one, the power still remains because the main purpose of integration by parts is one part of the equation will be simplified until it will be cancelled. So therefore, the u, when we derive, the power should decrease. So therefore, the best u that we could use is this x cubed. Okay, so u is equals to x cubed. So derivative of x cubed, that is 3x squared. If you could see, the power decreases. Okay, then therefore, what remains is your dv. So your dv is e2x dx. So derivative of that, hopefully you still remember. So for your calculus, this was discussed. So let's go directly. So if you integrate this one, because it's already from dv, when you make it into v, you need to integrate this one. So integrating that one, that is 1 over this power, copy, then copy it. Okay, so that's how you integrate this one. So just substitute. You have y e2x equals 4 times uv, that is x cubed times 1/2 e2x minus integral of v, that is 1/2 e2x du, that is 3x squared dx. Okay, simplify it. y e2x equals 4 times, that is 1/2 x cubed e2x minus 1/2 integral of, that is 3/2, sorry, that is 3/2 integral of e2x, because your 3 will be moved outside and the 1/2, that's why it's 3/2. Copy this one, x squared dx, and that. Then we'll simplify it further. So from here, move it up here. So we have y e 2x equals 4 times 1 half, that is 4 times 1 half, that is 2. 2x cubed e 2x minus 4 times 3. We have 4 times 3, that is 12 divided by 2, that is 6. Alright, that is 6. Integral of e 2x x squared dx. So if you could see, it's not yet done. We still need to integrate this one. So we need to make our u again. Our u is still x squared. Our du is 2x dx. And our dv is still the same. 2x dx. So your v is equivalent to 1 half e 2x. Okay. Now substitute it back. You have y e 2x equals 2x cubed. That is cubed, right? You have e 2x minus 6 times uv here. So this is very important. When you use integration by parts, you need to remember this one. Okay. So from here, you have u, that is x squared times 1 half e 2x minus integral of v 1 half e 2x du, that is 2x dx. So therefore, you simplify this one. You have y e 2x equals 2x cubed e 2x sorry, minus 6 times 1 half, that is 6 divided by 2, that is 3 x squared, 3x squared e 2x minus negative times negative, that is positive. Alright? So negative times negative, that is positive. So you have 6 divided by, so 2, you have 2 here and 2 here, so 2 divided by 2, that is 1. So you have negative 1 times negative 6, that is positive 6. Then integral of e 2x x dx x dx gap 1. So if you could see in this case, so here we have this one. So here we have, sorry. So here we have this one. And here we have this one. And in this case, we still have this one. Okay? So that's why I told that this will take longer. So the problem is very simple, but the solution is long, very long. Okay? So we have y y e 2x equals 2x cubed e 2x minus 3x squared e 2x. Later we can simplify this one. So okay, sorry, we could have u du again. So our u again is x, so that we could simplify it with the last time. So your du is dx na. Derive the x, that is dx. So your dv